In this video, I'm going to demonstrate how to write precipitation reactions, and the example I'm going to use is when a solution of aqueous sodium chloride is mixed with a solution of aqueous silver nitrate. The first step is to find the cations and anions from our starting salt solutions. So our starting salt solutions are sodium chloride and silver nitrate. So let's write those down. We have NaCl, and it's aqueous, and we also have silver nitrate, and it is also aqueous. The aqueous means that these are already dissolved in water. And since they're already dissolved in water, what we know is that the sodium chloride is not present as a solid, it's present as its cation and its anion pair. And the same with the silver nitrate. It's present as its cation and its anion pair. Now at this point you may be wondering, how do I know that this is NO3 minus, that it's a group and it's not separated as N and then 3 oxygens? And if you look in your lab procedure, we have a table of polyatomic ions. So these are things you have to start to recognize. But you'll see right here, I've already circled the nitrate. It's present as a group. It's a covalently bonded compound, and it has a -1 charge. So you may not know the charges of your polyatomic ions off the top of your head. So look at this chart. Look at this table to find the charges. And if you want to know how I knew that sodium was +1 and chlorine was -1, well, sodium is in column 1 of your periodic table, so those atoms will form +1 cations, and chlorine's in column 7, so those will form -1 anions. And since we just saw on the table that NO3 has a -1 charge, silver has to have a +1 charge because the charges of the silver and the nitrate group have to balance to form your silver nitrate salt, since this is not a charged species. So our next step is to combine our cation from one salt with our anion from another salt and determine if we get a precipitate forming. So Ag plus and Cl minus will combine to form AgCl. We have to decide, is that aqueous or is that a solid? And the Na plus and the NO3 minus will also interact. They'll see each other in the solution, the new solution that we're making. And we have to decide if the NaNO3 is a solid or is that an aqueous species. So now we have to go to our solubility table to determine if we have solids or precipitates. And I've already written down our 2 salts that we're questioning, silver chloride and sodium nitrate. And let's start with the sodium nitrate. So this table is grouped by compounds that are soluble up top and compounds that are insoluble down below. So you don't necessarily know where to start, but I'm just going to point out where things are. So this says soluble compounds generally dissolve in water if they contain, it says if they contain, and then one of the things that is generally soluble is nitrates. And if it's on this side, it will be soluble, and there sometimes are exceptions. In the case of the nitrate, there are none. So what that means is that our silver nitrate is going to be an aqueous species. It's going to stay dissolved in water. I'm going to write down dissolved. Now, the silver chloride, again, we're still up in this part of the table, generally soluble if it contains Cl minus, chloride. But we have to look over here for the exceptions, and Ag compounds are exceptions, so silver chloride right here is an exception. So that means that is insoluble. It will form a precipitate. So we're going to write S for solid, and this is what confuses students because this means solid. It does not mean soluble. So often students think the S means soluble. It doesn't. It means solid. It's going to form a precipitate. So now that we've identified our solid and our aqueous species, we come back here and let's write down our subscripts. So AgCl is S for solid, and sodium nitrate is AQ for aqueous. So now that we've completed steps 1 and we've completed steps 2, let's write the balanced molecular equation. So what we do is we start off with, on the left-hand side is going to be our starting species, sodium chloride and silver nitrate. So we'll write those down. So we have NaCl, and the subscripts are important, so you have to write them, plus the silver nitrate, going to form, and on the right-hand side of the equation, we put our salts that we identified. So what we have are AgCl, which is our solid, plus NaNO3, which is our aqueous species. Now at this point, you have to balance the reaction. Whenever you have only +1 and -1 charges, this equation is going to balance automatically. So this is already balanced, meaning we have 1 sodium and 1 sodium and 1 silver and 1 silver and so on. If any of these charges were +2 or -3, then you would have to go through the process of actually balancing this equation. So now we have completed step 3, so let's go on to step 4, which is writing the total ionic equation. So in this case, all you need to do is anytime you see the aqueous subscript, you're going to break these up into their cation and anion pairs. And anything that is a solid is going to be left as is. So we have sodium, which is a +1 charge, aqueous, plus Cl, which is a -1 charge, which is aqueous, plus the silver, +1, and the nitrate, -1, going to form our solid, so this doesn't change, AgCl, which is our solid, plus Na, again, +1 charge, aqueous, and NO3-, aqueous. So we've completed this step right here, and so now we're just going to go on to the last step, which is to remove our spectator ions. Remove spectator ions to get the net ionic equation. So the spectator ions are just the things that are the same on both sides of the equation. So look, you have an Na plus here and an Na plus here. They cancel each other out. It's just like having a +2 on each side of a math equation. Here you have an NO3- and an NO3-. So you want to remove these. So let's just cross them out. So Na plus we're not going to need, and we're also not going to need our NO3-. So I actually think about it as removing the things that don't go to form the solid. So what we're going to be left with are the things that are needed to form AgCl, which are just the Cl- and the Ag+. So now that we've removed the spectator ions, we just have to write our net ionic equation, which is Ag+, plus Cl-, going to form our solid, AgCl. So I just want to point out one thing, which is convention. And the convention is that you write the positively charged species first. So I have Ag+, and then I write Cl-. And also in my salt, notice that I wrote AgCl, so the positive species is first. So you wouldn't want to write ClAg. It's always positive and then minus. So to summarize what we've done here, we first looked at our starting salts. We broke them up into our cations and anions. Then we saw, we looked into see with all these cations and anions interacting, what are the new salts that could be formed. We determined if there were any precipitates by looking at our solubility table, and we found silver chloride does precipitate. Then we formed the balanced molecular equation by just starting with our two starting materials, sodium chloride and silver nitrate, And on the right-hand side just goes our two products that we identified with our solubility table. Then we form the total ionic equation just by taking the aqueous species and breaking them up into their cation and anion pairs. And anything that was a solid, we leave as a solid. And then finally, we removed our spectator ions, the sodium and the nitrate, to get our net ionic equation, which is just looking at the things that are used to form our new precipitate.